you're very familiar with inequalities, you've worked with them numerous times before. Of course, the word inequality means that it's not necessarily going to be equal to. So whenever we're dealing with inequalities, we're going to use any of the following symbols, either a less than to compare two quantities, or an equal to or less than, a greater than, or a greater than or equal to. One of those sorts of things, of course. Now, we're going to work with simple inequalities in this section, and then next section, component inequalities. You'll better understand the distinction between what makes an inequality simple versus compound, probably more when we get into the next section. But basically, what makes an inequality simple is that it should only use one inequality symbol. So in other words, you're only going to compare two quantities. Whereas with component inequalities, you're going to have multiple inequality symbols that you're using, and you're comparing lots of quantities at the same time and joining them together somehow. We'll get into that later on. So just to kind of briefly summarize, I guess, what makes an inequality simple. So let me write that out. So a simple inequality is going to be a comparison between, I guess it has to be exactly two quantities, using, one of those four inequality symbols. Not an equal sign, because that would be an equality, right? All right, so then just right below here, it says to graph each inequality. So each of these three inequalities here are one variable inequalities. So if you're only dealing with one variable, you can represent that in one dimension, which is just kind of a straight line, and you can do a real number line to do so. So if I were to graph this first inequality right here, what I'm really trying to represent is I'm trying to represent all of these numbers that x could be. And this statement right here says that x is a number that is greater than 8. So we want to represent all of the numbers that are greater than 8. So if this is where 7 is, and 8 is, and 9 is, then all of the numbers that are going to be greater than 8 are going to be all of these numbers right here, right? So I want to shade that, and it's going to go forever towards infinity. So you want to make sure you signify that with an arrow to say that it's going to go forever, include all those numbers. Now, if we're only talking about numbers that are greater than 8, then we cannot have x actually be 8, and we need to show that visually, and the way we do that is we're going to put an open circle right there where 8 is, and so you can think like it's empty, so we're not going to include 8 because, if that 8 was plugged in right there, that's not a true number statement because you can't say 8 is bigger than itself, right? So we'll use an open circle whenever we want to exclude a particular value. So the one right next door is basically just the same thing, except that it's got the equal to part, so we can allow x to be 8. So the only difference right here then, once I get this all drawn out, is that, of course, we will have all of the numbers greater than 8, and we'll draw the arrow. But now, because we can include 8 in this solution set, we will have a filled in or a closed circle to signify that we do want to include 8 as a possible value for x in that inequality. All right, and then the last one right here, just wanted to throw one where we've got x on the other side. So if you, think about it, it says that -5 has to be bigger than your numbers x. So if we plot out a real number line right here, and we put -5, -6 is smaller, -4 is bigger, this is saying that -5 has to be bigger than x, which means that x has to be smaller than -5, right? So realize that these two statements are the same statement, if you think about it, right? So what that means then is we do want all of these numbers below -5, since -5 is bigger than x. And we'd want to put an open circle because we don't want x to be -5. There's not an equal to underneath that at all. And then here it says to write the inequality that is represented by each graph. Okay, so pretty simple, right? It's basically what we're just doing, right? Inequality. So right here we've got all the numbers that are, higher than -2. So pick some variable to represent these numbers. So if I pick y, then what that means is all of these numbers here I'm representing with y, of course. And they are all above -2, so we can use the greater than symbol. And then say we're above -2, and you'll notice that it's got the open circle, so we want to exclude -2, or in other words, not include -2 in that solution set. And then for this one right here, we'll pick some variable to represent those numbers that are graphed right there. So maybe we'll pick a, how about, to represent those numbers. They're all below that particular number right there, which is going to be -1.5, since it's between -2 and -1. So we're going to compare a with -1.5. It's going to be all the numbers that are below, but you'll notice that it's got a closed circle, so we want to include -1.5 as a possible value for a.